Okay. Yeah. Bahareh Barati from Delft University of Technology.
Sorry? No, I don't have any idea. Okay, finally. Hi to you, all of you, and everyone who is kindly watching me online, and a very welcome to you all. After the two very interesting analytical and theoretical works, it's a perfect timing for some design exploration with materials, isn't it? Today I'm presenting our paper with Elisa, Giaccardi, and Elvin Karana on the making of performativity in designing and designing with smart material composites. What if you could stretch the performative potential of a material? What if you could bend the capabilities of the material to afford always new performances? Today's presentation is organized around the two main contributions discussed in our paper, namely a conceptual articulation of the smart materials as underdeveloped composites, and disruption of affordances as a design strategy in the making of materials' performative qualities. I will show our design explorations with electroluminescent materials to give you an illustration of the results of the theoretical and methodological contribution. Our paper focuses on designing with the smart material composites. Dynamic qualities of smart materials have offered immediate relevance to the HCI research and practice, particularly in transforming the commonplace flat screens and providing granularity between computational devices and material elements, as discussed by Coelho and colleagues, among others. Smart materials provide material components that can be tightly coupled with computers in creating computational composites, an approach that Valgerda and Redstorm put forward in exploring the aesthetic and expressiveness of computers as a material of design. Excuse me for the delay. So, get back to smart materials and the background on that. The stimular-responsive dynamic qualities that unfold over time and in relation to the context of use render the performativity of smart materials particularly interesting as an entry point for designing with them. With the term smart material composites introduced in the paper, we aim to foreground the always underdeveloped state of smart materials that enables and derives creative processes with them. We argue that the designers need to keep an open mind about both underdeveloped technical and experiential qualities. So instead of taking the materials as given, finished and to be applied, take them as open, unfinished, and to be designed. This theoretical articulation of the smart materials as underdeveloped composites and its implication in stretching the performative potential of these materials is the contribution of our work, which I'm going to elaborate further with the case of electroluminescent material. Just to give you a little bit of context, the choice of electroluminescent materials as a case for our research is motivated by the EU project Light Touch Matters. The project proposed upstream collaborative materials development and involved product designers in early stages of developing composites of thin film luminescent materials and piezoelectric polymers. To identify the design space with these underdeveloped composites, we initiated several material-driven design projects departing from unprocessed electroluminescent materials. Electroluminescent materials, or in short, EL materials, are materials that emit light when subject to changes in high voltage electric field. They are available off the shelf in the form of EL wires and panels and are used in various applications, including safety-related products and interactive art installations. All design explorations involved an early material understanding step, in which we put forward and supported our design students with hands-on workshop and theoretical explanations on EL materials as underdeveloped composites. In other words, instead of representing EL materials as a finished and finalized composite awaiting to be applied in creative applications, we equipped the students with a finer-grained understanding of the materials through making and tinkering with the components and learning about the layering structure, working principle, and so on. The way we approached these early workshops were similar to the work of Sandström and colleagues on digital technologies, which is, by the way, a very interesting work, which aim at demystifying and unblackboxing the technologies to the designers in multidisciplinary development projects. Electroluminescent material samples, which I have many here, and please feel welcome to come and visit them, are composed of 5 components: a substrate, which can be transparent or non-transparent, conductive or non-conductive, 2 conductors, at least one of which must be transparent to let the light go out, and phosphor and dielectric insulator, which are sandwiched between the 2 conductors. Here you see a video in which my student, Stanklas, is screen printing and curing a layer of silver conductor. So making a basic electroluminescent material sample involves repeating this process 3 to 4 times. So he's putting it in an oven for 10 to 15 minutes. And then the sample is ready for the next layer to be printed on. Our material-driven design approach in understanding the EL materials enables us to investigate what the material may offer in response to the designer's skillful bodily engagement in an open-ended design situation. It also encouraged a flat hierarchy of the technical and experiential qualities in defining and shaping designers' understanding of the material's potential. As a result of the conceptual and methodological positioning, the creative process accommodates not only designing with the electroluminescent material, but also the material itself. In the following slides, I show how we managed to stretch the performative qualities of EL materials. When we talk about affordances here, we mean the action potential or action possibilities revealed in the process of tinkering and making and interacting with the created material samples. In our explorations, we identified 4 operation levels or categories in disrupting the affordance of the samples to give light. They are matter level, structure, form, and computation. I will go through them one by one. So, matter level. The first series of explorations show how we influence the performative qualities through a certain alteration of the matter, meaning ingredient. The realization that the solid electrodes can be partially replaced by liquid conductors, inspired by the work of Franinovich and Franske, steered further tinkering with water and water-based substances and resulted in novel performative qualities, as you saw in the video. So the second, structure. The second design exploration takes interest in hacking the layering structure and resulted in creating a sample that did not emit light unless the 2 parts were assembled and pressed against each other. The open structure also allowed the light output to vary corresponding to the conductivity and contact area of the materials placed in between the structure. Our paper provides two examples of form-related explorations. On the right side, you see the created sample with a serpentine top electrode print. Using multiple connection points, the light gradient would be moved along the printed trace. A similar principle of using multiple connection points in diversifying the performative qualities are shown in the video. The sample involves an array of small bumps with metal caps on a sheet of silicon. With this formal alteration, our students condition activation of the phosphor in each bumps to making contact with the adjacent ones, stimulating, in this case, the kneading action. And finally, in another exploration, we followed the usual making process in fabricating a performable object. Initially printed as a 2D sheet with stripped light pattern, the sample is then cut and shaped into a hollow cylinder. We then realized that the deformation can control the amount of surrounding light reached inside the cylinder. By incorporating a light sensor inside and modifying the inverter, we enabled the light output to change in accordance with the action of twisting. As you may have noticed, all the EL samples we made stayed off or almost off when you use the inverter to switch them on. It is only when you pour water on it, using your finger to wet the surface, press it against the green gooey substance or twist it open, that the samples light up corresponding to your bodily action. By disruption of affordances, we in fact tap into the norms of efficiency encrypted in the production of smart materials that we were able to challenge through variations and hacks of their matter, structure, form, and mechanisms of computation. Our explorations bring forth a sensitivity to flows and transformations of materials, to borrow from Ingold, by a conceptualization of the smart material as an underdeveloped composite. Thank you very much for your attention.
Questions? I have one anyway. So, very nice talk, especially the videos.
Thank you.
So, what are your plans next then? So, where are you taking the smart materials and the way we interact with them?
This is actually one of the many explorations that we are doing, not only with the smart materials, but also with other materials. Well, they are called material-driven design, basically explorations or approach. And so these strategies, on one hand, they help us to diversifying the type of samples that we make, mainly in collaboration with material scientists. So they give us a sort of distinction and articulation of what the contribution of design could be to materials development. And we are working on that. We are expanding, basically, based on these examples. We are reaching out to material scientists who are working on these materials. We hope that we can bring design influence, basically, to these upstream collaborative projects.
Any other questions?